It was discovered in 1988 from observation of type 1a supernovae that the universe appears to be expanding at an accelerated rate. If the universe consisted of just matter attracted to itself by gravitational forces, then the expansion would be expected to slow down gradually, with the scale factor A increasing as time to the power 2/3. To explain the acceleration, a cosmological constant lambda was added to the equation of state that acts like a negative pressure and causes an exponential expansion. The observed expansion rate is then reproduced if the cosmological constant contributes 2/3 of the mass energy content of the universe and gravitational matter just 1/3. This unknown form of energy is generally referred to as dark energy. But it is surely unsatisfactory and incorrect to believe that the universe is dominated by a completely unknown substance in such a very large proportion, and with this precise ratio with respect to matter. Particle physics does indeed predict that space may contain vacuum energy, but not in anything like the quantity needed to satisfy the current cosmological model. There therefore must surely be some other cause for the deduced accelerated expansion, one that doesn't involve inventing a completely unknown substance or form of energy. The lambda CDM model is based on the so-called Friedmann-Lemaitre or Robertson-Walker metric, FLRW metric. The expansion is expressed by multiplying the spatial increment ds by the scale factor A. Time is regarded as some uniform quantity unaffected by the universal scale. Based on this model, it then turns out that the scale factor A seems to be increasing as time squared. Armed with this information, we can now begin to address the issue differently. Suppose that time has not always passed at a constant rate. A few authors, including Milne, Masrelier, Senovilla, and some others, have indeed proposed a varying rate of flow of time. When Einstein proposed special relativity in 1905, he postulated the invariance of the speed of light, which was later formulated by Minkowski as time and space being linked in a four-dimensional framework. Einstein did not know at the time he postulated special relativity that the universe was expanding. But it does seem almost obvious to me that if space is expanding, time will inherently expand as well, in order to preserve the symmetry found in special relativity. Such an idea then leads me to rewrite the metric to express this space-time expansion. Next, assume we remain in the same place, so ds equals 0. Then we have dt dash equals a dt. Since clocks indicate the proper time t dashed, and a equals 1 in the present, then we can write dt dashed as a function of a equals a dt dashed when a equals 1. And this can be interpreted to mean that the clock ticked more slowly in the past than in the present, and it would speed up into the future. Of course, we can't instantaneously look back into the past to check this hypothesis, but we can observe events taking place in the past that occurred a long way away, such that the light we observe from distant galaxies, we find that this light is red-shifted. This is generally understood to indicate that the universe is expanding and that the wavelengths of light have been stretched by the expansion of space. However, there is a different explanation related to what I'm saying here. I'm saying that due to this cosmological time dilation, where time was slowed down in the past, the frequencies or clock rates of atomic vibrations were also lower, and this is the cause of wavelengths being redshifted compared to light sources in the laboratory today. In the FLRW metric, time is considered as flowing at a constant rate. I shall denote this time with the letter tau. It is basically the same as t dashed at a equals 1, the present clock rate. In the diagram I have indicated schematically the accelerated expansion of the scale factor. In terms of tau, the universe is expanding as tau to the power 2, tau squared. But if we convert this to the time published in my metric, we can see from the equations in the diagram that we obtain a 2/3 power law for the increase in scale factor A. This is exactly the deceleration you'd expect from a mass-dominated universe. This means that we can describe the universe as entirely mass-dominated if we take the expansion of time into account. There is therefore no need to invent dark energy to explain the accelerated expansion, since that observation is based on the false assumption of a constant timescale. If my postulate is correct, what we essentially have then is a mass-dominated universe whose expansion is slowed by gravity, but where the expansion of the time coordinate self overrides this deceleration and gives the appearance of an acceleration. Dark energy is therefore an artifact and should be erased from the scientific agenda. The cosmological model is in need of repair to include an expansion of time in addition to the expansion of space, and many of its parameters will probably need major revision.